Hello friends, welcome to my channel. Let's have a look at problem 2374, node with highest edge score. In this video, we are going to share a solution based on the use of weighted in degree. First, I'll read through the problem statement to digest the requirements, and then we share the code and in between explain the details. First, let's look at the problem statement. We are given a directed graph with n nodes labeled from 0 to n-1, where each node has exactly one outgoing edge. So in other words, the out degree is 1. The graph is represented by a given zero-indexed integer array called edges of length n, where edges I indicates that there is a directed edge from node I to node edges I. The edge score of a node I is defined as the sum of the labels of all the nodes that have an edge pointing to I. So we are required to return the node with the highest edge score. If multi-nodes have the same edge score, return the nodes with the smallest index. So here are two examples. Let's look at example 1. So in example 1, the graph actually contains two connected components. So in this example, the output is 7. So for node 7, the score is 5 plus 6, that is 11, right? So you can interpret example 2 similarly. So before we look at the coding, so let's look at the constraints. First, the number of edges is between n is the number of nodes, so n is in between 2 and 10 to the power 5. So 10 to the power 5 is a decently large number. So edges I, because it represents a node, so it's in between 0 and less than n, right? So edges I does not equal to I. In other words, there is no self cycle. So with that said, so we're ready to do the analysis. So here, as we mentioned at the very beginning, so we are going to use weighted in degree. So the in degree actually counts how many edges pointing to a node directly. So weighted, so here I'm going to use the weight of the node label. So as this problem is so direct, so we directly go to the coding part. So afterwards, actually we can print out the in degree table for digest. So now let's look at the coding part. So because the length of edges will be the number of nodes, let's first track this information. So n is the number of nodes, and then I'm going to make a in degree table. So this will be 0 times n. In other words, so this list has a length n. So initially we set the degree for each node is 0, and then we are going to iterate over the edges list, right? So for start, end, in enumerate edges. So the index will be the start node, and the end will be the end node. So we are going to compute the in degree of the end. So if we compute the vanilla in degree, so we just need to increment it by 1. However, here we need to take into consideration of the node label, so we add start. So actually it's a start times 1, or 1 times start. Start is a weight. So let's just add start directly. So this finishes the computation of the in degree list, and then we are going to try to get the max degree. So max degree, and also we want to have a result node. So first I'm going to set the max degree to be a smaller one, let's say 0 or -1 if we like. So let's put -1 here, and then we iterate over the in degree to get the largest one with smallest index. So this is basically another for loop. So for node and degree in enumerate, so in degree. So we are going to check if the degree is greater than the max degree. So if this is the case, so we're going to set the max degree to be the degree, and then we also update the result to be the current node, right? Then afterwards we return the result status. Notice that if the degree equals the maximum degree, so we do not update the result because we need to return the smallest index node. So with that said, I guess that's about it for a solution. Let's now do some check. Yeah, this passes the first example, right? So now let's look at the second example. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the generic case of. So now, as we mentioned, so we actually can print out this in degree table to get some feeling about the in degree of all the nodes. So let's run this. So you see the in degrees of the nodes for node 0 is 3. For node 2 is also 3. So we need to return 0 for this example. So with this side, I guess that's about it for this problem. And also it's the end of this video. Thank you very much.